All right. Well, that was interesting.
Linux philosophy.
Huh.
Oh yeah, Linux philosophy.
Philosophy.
Oh, Linux definitely has a philosophy.
That's no fun.
You of all people would, of course, delve into it.
Well, it's not too much, right? It's only what, slides? It's not bad.
Not bad.
We're not gonna. It's not like it's. Oh, whatever. So today we'll talk about how you do compilation in Linux, or at least for this class. Now, obviously, you could use an IDE to do all your compilation. That's what you did in Java. But here we're going to use the command line to do it. And in reality, the GUI or your IntelliJ or whatever you're using is really just pasting things together and running command line programs for you. So this will force you to learn how to do it. And even in the workforce, a lot of people still use the command line. Specifically, we're going to learn make today, which, while is a very old program written in the 70s, no joke, people still use it. Google did their compilation using make. All right. Linux philosophy, there's really just one rule of thumb. Everything is a file. Almost. Okay, almost everything is a file. But really, it tries to make everything a file. Your device is considered a file. Directories are files. You can actually write to memory by reading and writing from a file. Everything is a file in Linux. Now, of course, programs can use disk files, serial ports, other devices, basically by opening a file. And this makes sense because, in general, when you're interacting with something, you just have input and output, like a file. So you can read from the file and you can write to the file. Let's see, file has some administrative information, create modification dates, permissions. Properties are stored in the file's inode. When you go into OS, that'll make a little more sense, but files inside of Unix have a couple of extra information associated with them. They're not just the contents of the file. There's other stuff as well.
So wait, what's not a file then?
The operating system?
What is not a file? Right, technically the kernel, well, the kernel is a bzipped file. It can be whatever type of file you want. I cannot remember. It's really, because you can always map something to it. That's the trick. Oh, what would it be? All your device drivers are files. I mean, I could write a device driver that doesn't act like a file, but then that would break the Linux philosophy. So everything should be a file. Directories are files. They're just a file that points to other files. So what we got, each directory links a link to files inode. Remove the file name, you just remove the link. So if the number of links of a file reaches 0, the inode is derived. Okay. Not too important, too much of the details. Just realize, again, directories are files. They're just a file that contains pointers to other files. And since a directory is a file, if it's pointing to a file, that file could be a directory, and then you could just keep drilling on down. Directories continue. I wonder if I spelled that right. So, yeah, it looks like the INE are switched. Anyways, files arranged in directories. There are a lot of important directories to learn about. Well, not too many to learn that you need to learn, but it's important to understand it. If I do an ls on slash, slash is the beginning of the entire system. See, what do we have here? Bin, which stores a bunch of your binaries. Boot, which in general stores all the information in order to boot your operating systems. Most of the time, that's where your kernel is stored, as well as maybe your bootloader information, grub or livo, etc. Dev, that's where your devices are. So you can access your devices through dev. Etc is very common to store all your configuration files in. Home is where a lot of the user's home directories are located. I'm going to skip down a little bit to lib. Lib is where your libraries are. In Windows, these were your DLLs. In Unix, they're called .sos, but they're essentially the same thing. Lib32, Lib64, okay, 32 versions, 64-bit versions. Skip lost and found. You might have a mount point. There's other ones, and they each have their use. SBin is for secure bin. Usually those are only the programs you want root to be executing. Do we have anything more? Lib, dev. All right, so I went through all of them. Great. Any questions so far? Make sure I stop. Good. So you can't have a structure. Maybe this will help out. You have slash, and you can go into bin, dev, or home. Home may have two other people, Neil and Rick, and Neil may have mail, letters, and programs as well. So that's how it's laid out. Hardware devices are mapped by files. For example, your CD-ROM drive, ooh, that's an old slide, might be mapped to /dev-/HDC. Nowadays, it's usually SD and then some letter A, B, C, D, E, F, G, etc., etc. And that's where the device is. So if you want to mount it, aka you want your CD-ROM drive to be presented at some point on your computer, you would mount it. So you would mount and -T ISO 9660, that's just the file system. So we're mounting this type of file system from the device /dev HDC to the directory mount/CD-ROM. And what that does is it makes that directory now point to the contents of your CD-ROM drive. You can do the same thing with USB sticks. Most operating systems, so if you installed Linux, or Mint I should say, or Ubuntu, it'll do this mounting for you. But if you put something in and you don't see it, you may have to start looking, Google mount, how do I mount my blah, blah, blah from the command line?
Blah, 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 blah. Is that what I have to tell Google?
How do I mount my CD from command line? How do I mount my USB stick from the command line? Et cetera, et cetera.
Blah, 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 is the name of the driver. If you want to-
Blah, blah, blah is the driver.
Somebody plays me well and
Blah, blah, blah. Dev console is your system console. Error messages, diagnostic are sent to this device. It's usually your active virtual console. Basically, it's what's driving what we're seeing. TTY, fortunately, I can jump to it from my computer, but then anyone who's trying to record will not see it because currently the record is only happening on TTY7 on my machine. Most Linux machines have multiple TTYs. And TTY7 by convention is where your GUI is running, but you can have TTY1, 2, 3, 4, etc., which will just display a standard login, and you can do a lot of different, run all your commands. And you get to those, by doing Control-Alt F1 to go to the first one, F2 to go to the second one, F3 to the third, etc., etc., and then F7 would put you back to your GUI. DevNull. So DevNull, one of my favorite devices. All output written to DevNull is discarded. So if you just want to ignore something, pipe it to DevNull. It'll no longer bother you. So any unwanted output, students' emails, is often directed to a DevNull. Student email complaints, I should say, or rants. I read all your emails and try to respond, but I get some good ones every once in a while. So if you wanted to, you could copy something to an empty file, and that would create an empty file. Or if you have too much output, just pipe it to DevNull, and it'll be ignored. That way it won't flood your screen. Let me show you what that is, since I'm kind of just talking about it. I can do SEQ1 to 1,000, and it gives me a whole bunch of numbers. Let me stop that. But if I pipe it to, oops, I'm sorry, to DevNull, all that output is just discarded and ignored. All right. Okay. So that's a quick little bit about Linux philosophy. Hopefully, you'll need to keep those in the back of your mind while you're coding. And now we'll start talking about actual compilation. Right now. Any questions about the philosophy? Kind of a high-level view. Yes.
Why is Linux still preferred over Windows or Mac?
It's
That's just the opinionated.
That was a pretty opinionated question. For me, it's the interface. The command line tools have always been better under Linux than under Windows.
Okay.
Can you switch, the little X to exit out something to the top left on Linux?
Oh, yeah.
Can you move it to the right side?
Yeah. You could write your own Windows manager to do anything you want. And there's plenty that you can use to configure and set up different defaults about where everything is located, having no borders on things, as you can see on mine, or having really extreme borders for whatever reason you want. Yeah, it's completely configurable. Okay, any other questions? These are good questions. All right, okay. It's a programmer or sysadmin. You need to know how to compile. So we're going to learn in these slides GCC, but in reality for this class we'll move directly to G++, which compiles our programs. Debugging, so that's GDB and DDD. And what do we have? How to automate compilation with make. Make is going to be your friend. Please learn it and use it. I will eventually start giving you make files to help you out, but make is really going to make your life simpler. Ha ha ha. All right. How to do memory analysis, and that's with Valgrind. That's how they want you to pronounce it, Valgrind, not Valgrind. They get angry about that. Whatever.
Valgrind?
Why they
Valgrind.
put the extra letter in though?
Apparently it's from Norse mythology, and that's how it's pronounced.
That's supposed to be pronounced what?
Valgrind.
Really?
Yes.
That's fun.
It is. Apparently I was pronouncing it wrong last semester.
Yeah, I guess
Named
so.
after the Viking warrior Valkyrie. After his long conquest.
And then we'll talk about how to do performance graphs with GNU plot and actually gprof, but we're not going to do that today. Hopefully we can get to Valgrind today. All right, let's actually start coding, right? So let's go ahead and jump over, and I'm going to go and CD into our courses. 315, spring 2017. Do I have some? Ooh, I have some class code. Carla Sydney timings. All right, we'll go and make a directory called first. Jump into first, and then let's go ahead and make our main dot. Let's see, we're doing this one a C file. We'll make this one a C file. Good. So include standard io.h int main int argc. So standard io.h is the standard
Can I turn the lights on?
Unix, and I was about ready to say. Hold on. Standard io.h is a standard library for doing input and output under C, and I've realized that this is very hard to see, so we're going to go ahead and load up gvim. How about now?
Yeah.
How's that?
It's a little bit here.
Okay, good. Int, the way we'd start call is int main, int argc, and then char star argv. We'll get a little more into that later, but notice that your main function returns an integer, so your programs under Linux actually have a return code. Int argc is the number of arguments to your program, and char star argv are the actual argument list being sent in. And we'll go into a little more detail later, probably not today. And what do we want to do with our first one? Okay, we'll just print off hello world, \n, semicolon, return 0. All right, let me jump back. By the way, you can alt-tab in Linux just like in Windows or basically every other operating system. So if I want to compile this, I can go gcc main.c, and oh good, there were no problems. So it just compiled it. Well, what did it produce? If I do an ls, I have something called a.out. If you want to run your program, go to the directory you're supposed to be in, go /a. And I'm going to just do tab completion, and press enter to run your program, and boom, there it is, hello world. Any questions on what I just did?
Do it again slower.
So over here, so here's the simple code.
I'm just confused on how you got it. Just go back to the other sheet. So you did vim main.c.
I did gvim. So let me close gvim.
GVim is different.
Yeah, gvim is graphical vim.
So you
And
have
then
to
loaded it up.
GVim.
Now, a nice thing about gvim is it gives you your terminal back. So you can go ahead and do more commands afterwards while you're editing the file.
Nope, that didn't work.
You may have to install gvim.
How do you do that? This is
sudo apt-get install, I think it's vim-gnome. It's installed under my machine, yeah. That's how you can do it from the command line.
Sudo apt what?
Sudo apt-get install vim-gnome. Really, it's pronounced gnome, but
Yeah, why not?
I like saying gnome.
Unable to locate.
Try -gtk.
In that, retype the other thing and then do that.
Oh, just hit up arrow and delete the last name, go GDK. Oh, no, it wants to do that. And then you may also be able to type in gvim. I don't know what your package manager does. All right. So I gvim'd the file, and then I did gcc main.c, and then I did an ls and found out that there is an a.out file. Hey, look, by default it made it so it was executable for me. If I do file in the a.out, it says it's an ELF file. Extended Linux format file, 64-bit, executable, and some other information that's kind of confusing. Oh, look, it's system file. Dynamically linked, et cetera, et cetera, et cetera. And it has not been stripped. All right. So that means that we can run that ./a.out. All right. Did that help?
We'll see when we watch the video again.
But if you're using Atom, it doesn't work the same way, right?
You just edit your file and then go back to your terminal and type in the command.
Oh, okay.
I mean, I could use gvim, I could use nano, you can use whatever. Just this is just editing text, right? I mean, I do a cat on main.c, it's just editing the text of the file. All right. So what file was generated? A.out. Well, that's not too descriptive, so maybe we should, let me go ahead and remove that. And if you want to actually tell it what output to call it, you do gcc space -o space what you want to call it, and I'll just call it test, or maybe I'll call it first, and then compiling main.c, hit enter, ls-lh, and now it's called first. I run first, and boom, it's gone. All right, quick question. Anyone notice something different about the executable file between Linux and Windows? A what? In Windows, what is your executables usually end with exe?
Oh, I said X. I knew I had an X.
Oh, it had an exit. In Linux, it doesn't matter what it ends with. It could end with exe or whatever you want it to end with. In fact, the dot is actually completely superfluous. Linux doesn't even care what it ends with. So we could move first to first dot whatever. And you'll notice I can now execute first dot whatever, and it does the same thing. It doesn't have to be first dot exe. You can just be whatever you want it to be. And the reason for that is your execute permissions are based or are built into the files themselves. All right, any questions so far? Try and take this one at a time. Doing good? All right. All right, with debugging, you want to compile in with -g. If I did a file on first, it doesn't say anything about debugging, but if I do gc, we'll just actually up arrow, -o first, -g. So with debug flags, file on first, does it actually tell me? No, it doesn't say that. It actually has the debug flags in it. Well, you can run it again, and now it has first, but the executable has something called debug flags built into it, so you can link or hook up a debugger and actually get back some useful information. And I'll show you that later on. You can improve performance by telling the compiler to add optimizations. GCC-O for optimizations, that's big O, -little o to tell it what the output is, and main.c. This will optimize the code and actually do some code improvements to improve the performance of your code. Any questions about that?
Ooh,
it decide what to improve?
So, to answer that question completely would require an entire course. But to give you the summary, there's a lot of research to decide what is actually a code improving transformation. Some of them are pretty obvious. If you can take 3 commands that are basically equivalent and transfer them into one command, and they all take the same time, everything being equal, obviously, 3 times the performance, right? But there's a lot of other things going on. GCC-O does a lot of the standard optimizations that pretty much always improve your performance. And there's different levels. -02 will improve your performance and do what it can to reduce the size of your executable. So it's keeping both performance and executable size in mind. And the reason is that so your program doesn't get too big. 03 is very aggressive in its optimizations and usually ignores program size and will increase the size of your executable if it can find ways to also improve your performance. What those all mean and what those actually do for you, you will find out later. Architecture, more about what's going on, or if you take a compiler course. But for now, just stick with -O or -02. -02 is usually a really safe optimization level. Good question. Any other questions?
So does it actually change your code?
Essentially, it changes the executable that is produced.
Okay.
Your code stays the
So it
same.
won't change all that.
Right, it doesn't change that fast.
Okay.
Now, why wouldn't you do this by default? There are many reasons for it. First off, it can make debugging more difficult. And second off, it takes longer to compile your code. So if you have a huge project, it's taking forever to compile, removing optimizations will at least get you through the compilation phase and see if you have any compile errors. And then later you can put in some optimization flags. All right. Let's see what we got. -O. So error messages. So when you do see, let's go over here and let's do something that doesn't make any sense, like get rid of that semicolon. Compile, and then it'll say, notice it goes main.c, line 6, character 5, error. So there is an error, which means it was not able to compile your program. Expected a semicolon before return. All right, well, that's pretty simple. Over here on line 6, it hit a return, but it needed a semicolon before it got there. Well, that's because up here we didn't put in a semicolon in our previous line. So the compiler does give you some compilation information. Let's see, warning. What would be a good warning message? Actually, if we get rid of this return, and I'm going to just add warn all. Warning, control reaches end of non-void function. Warning means that the compiler is trying to tell you, hey, look, this is not good practice, but I was able to compile your code anyways. So please fix your warnings, even though G++ will go ahead and compile your code, because if you start getting some really weird errors, it might be because you messed up memory somehow, and the warnings was trying to tell you what was going on. If you didn't put a return statement in a function in Java, what would happen?
An error would be thrown.
An error would be thrown. Would your program compile or run?
No.
But in C++, it's going to.
That's what makes C++ so nice over Java.
It's good and
Ooh, why is it good and bad?
because it compiles, but it could have issues running.
You have issues running, and then you may not know what the issue is.
Well, you have more power in your hands with C++.
That's true. C++, what was the phrase? You have the 2 biggest guns in the industry and no holster to put them in.
Yeah, sounds about right.
So,
Just hold them in your hands.
You're holding them in your hands the whole way, trying not to shoot yourself.
What's the difference between GCC and G++?
GCC is GNU C compiler, G++ is GNU C++ compiler.
Oh yeah, that's right. That's right.
So very little difference.
Huge difference. Sorry.
GCC compiles as C or C++.
It all depends on your system.
I think it's
In the past, it would compile either. It would actually look at your file and determine what tool to use. Recently, they've moved to making GCC only compile C code and G++ only compile C++ code.
So we're working in C.
You're working in, right now I'm using GCC just to point out the difference because I'm about ready to move into G++. But we'll be using G++. And in general, G++ will compile all your C code. In general. But the opposite is not true. So yeah, -wall or warn all is actually what it is. It's useful for improving the quality of your source code. So please, when you compile, do pass the -wall argument. So the compiler is going to try and help you out and fix some of the issues for you. Because now, if I go back here and I put back that return statement, it doesn't give me any warnings. So the code is passing at least the warning check. Yes?
Does it help to pass in like the standard as well? I forget what it is.
Oh, yeah, you could do like -std equals C99.
Yeah.
Yeah, so there are different standards to C and C++. If you wish to use a certain standard, I forget, depending on your compiler, is which one is currently being used. I'm not going to use too many of the fancy latest stuff. Was it C++ even 14? I'm not going to use, and I'm probably not even going to use stuff from C++ 11. So the default compilation for this class should work just fine. But that is important that if you are using a different standard, that is not the default of the compiler. Do pass it in with this type of flag. All right, so that was a C program. I'm going to go ahead and exit out of that with :Q. I'm now going to do a first.cpp file. So I'm inside Vim. Let me go ahead and give you at least a quick pointer of what's going on. When you start Vim, in this case gvim, you're currently in text, you're basically in executive mode or editing mode. There's nothing in this file, so I need to actually start going into insert mode. And the way I do that is by hitting the I key.
How long did it take you to get efficient with it?
A couple of months. I would say after a month, I became about efficient with Vim as I was by using Notepad. So there's definitely a load up time. But then afterwards, there's no competition. Vim is way faster.
Right.
I'm going to hit I. Notice in the bottom right, I'm now in insert mode. If I would ever exit insert mode, I hit escape. And notice insert went away. I hit I again. I'm back in insert mode. And now I can just type like I do regularly, IO stream. And then it's still main int argc char star argv. Ooh, the default C indentation is not working. So let me reopen this file. There we go. That was better. Oh, how did I do that? If I'm on one line and I want to go to the next line and go into insert mode, I hit lowercase o. There we go. So I'm back to, okay, what are we doing? Oh, we're doing hello world. Good. So std : C out, hello world. I'm going to just put a backslash in there and then return 0. When you did C++, did you do it this way, or did you always do using namespace std?
That one.
Okay, if you do that, then you don't have to do the std : C out. It's just assume in front of it. Yeah. But I'm directly referencing it here. By
Can we do the other way?
yeah, of course you can do using namespace std. All right, if I go back here and I try to do GCC on first.cpp, it's going to give me all sorts of problems because none of what I did made sense. But if I do G++, I will do -o. Ooh, that was close. -o first on first.cpp, then it compiles just fine. And now I can run it. So if you're using C++ code, use G++. From now on, we will always be using G++. I wanted to show you there are other ways to run other compilers. Fortran is usually like G77 or something, or G90. But we're using C++. All right, any questions on this? Oh yeah, to save. In VI, I was in insert mode. I hit escape to get out of it. I do colon. Notice my cursor is in the bottom left. W writes it out. Hit enter, and then it was written.
Which means it was saved.
Yes.
What's the 100 HC and the 7 up?
7 lines. Is that 108 characters? Really, 108 characters?
Okay.
I'm on line 6, character 13, and currently all of it's being displayed. All right.
You can hide stuff.
Well, the file's too big. It can only show a portion of it. All right. Any questions? Compile and run. All right. If you have multiple files, you need to put them all together in order to get them to compile. So, did y'all have multi-file? No, y'all never had multiple. Oh, wow.
Wait, what?
You never had a lab where you had to use multiple files?
Oh, yeah,
Header
we did like
files?
text file and then like our.
Multiple C files, multiple CPP files. Oh, well, all your labs here will have multiple CPP files. Hold on, this is going to look really, really bad, and then Make is going to come to the rescue.
Okay.
All right. So realize
Maybe
how
we can
bad.
make our lives easier.
Yes, Make makes your life easier. Okay, so we have main.cpp, and if we wanted to, I'm going to open up a new file by doing tab new. Let's see, what should I call it? Okay. Second.cpp. All right. And this one won't have a main. I'll just have void print function, and I'll have it do std : c out to do
Hi there.
hello. Oh, okay, sure. Hi there. All right. So I was over. GT goes back to the other one. If I want to, let's see, use this file or use this function, I could try and call the function normally from right here. Did y'all do header files and compilate? Y'all did.
All in one though. No, we were just discussing that.
So
It's all in like one.
y'all, so everything you did was in one file. Ooh. All right.
I made a C++
Yeah, you just
sandwich.
divide it up. Like it'll be like the top, and then like obviously the bottom.
Oh, yeah,
C++
yeah. Like we make like
sandwich.
the name of everything. Like we declare everything at the top, and then like all the
Prototypes.
functions would be like everywhere else.
Okay.
Throughout one file.
So- You would think that with, I have print defined in this CPP file and first defined in this CPP file, and it might actually work. Let's find out. First.cpp, second.cpp. Nope!
No.
Print was not declared in this scope. What does that mean?
Need to include the
I didn't like it.
I didn't include, what did I not include?
Second as a header file. Or
header, right?
Right, I need a header file. Did y'all do header files? No header files. All right.
Isn't it a header file the hashtag include IO stream?
That is the header file for IOStream, but you can write your own header files.
Yeah, you can create your own.
Okay.
Why am I not
We
surprised?
might have learned.
We did learn it.
All right, so let me make a header file, tab new second.hpp. When you create a header file, the first thing you want to do is do your preprocessor directives. Remember pound if defined, if not defined, or define and end if. Did y'all do that? Okay, all right.
We missed a lot.
Whew, that's fine. So, if not defined, we'll just call it second_HPP. All right, oh, how did I copy and paste? YY copies a line, P pastes that line, CW deletes the current word I'm on and then puts me back into insert mode, define. So, if not defined second_HPP, define second_HPP. And since this is an if statement, we need to have an end if. What this is saying is that this is preprocessor, meaning that before your code is compiled, GCC is going to go in and run all your ifs and else if defines and everything else in the preprocessor to generate the final code. So, in here is where you'd want to do your function heading. And y'all did this by putting them up top function and then later, okay, great. So I can do void print, which is the function heading. Function heading for print. And what this is saying is it's just telling the compiler, hey, look, there's going to be a print function at some point. It's going to be defined. All right. Now, just because I've defined the header file doesn't mean it's going to work, because if I try and compile first .cpp first.h, second.cpp, it's still not going to work. What has to happen is inside of first, I need to actually include second.hpp. What this does is it goes in to the second.hpp file and essentially copies that entire file and puts it right there. That's really all it does.
So how we did it in one, now we're splitting it up.
Now it's splitting
and
it.
then we're adding part by
So the include is taking the contents of that file and essentially pasting it into your current one. That's all it's doing. It's the same. I could literally copy and paste it in if I wanted to. Now, I go back over here, I compile it now, and ooh, see how it's not defined in standard? Right, in second.cpp. Can anyone tell me why that happened? Notice I got rid of a previous error, but I didn't get rid of the error in here.
Because you didn't declare it.
I didn't declare.
You didn't include IO.
Yeah, I did include IOStream.
Oh, this is okay. So this is basically inheritance as well, right?
No?
There's no objects.
I see how you roll.
But I see what you're trying to say is this file is inheriting the contents of IOStream. You can think of it that way. And that's not that. Yeah, that's fine. You can think of it that way. So now second.cpp can use anything from IOStream, and then first.cpp uses anything from IOStream and our second.hpp file, which just is declaring print. And then I go back here, I can now compile it all into one, and if I run it, it actually runs hello world and then hi there, which was in our second.cpp. Okay.
Can I see how you like what you put in second.hpp?
Sure. Just to recap real quick, back in my command line, ls.lh, notice that in my directory I have first.cpp, second.cpp, and second.hpp. So I have first.cpp and second.hpp.
So, since, like, why do you put that in first, though? Just
Put what in first?
the second, like, why do you put the includes, like, second and first? Does that, like...
Hold on. So I think your question is, first off, it kind of doesn't matter if it's in this order or the other. That doesn't matter. But if I took second and I put it after I used print, it goes back to my first error, print wasn't defined. So the whole point of including second was that before I actually wrote code, I basically told the compiler, hey, look, this function is going to exist, and this is how it's used. Good question. Yes?
Kind of going back from like Java last semester. So second HPP would be the interface file from Java,
So, yes. That's a good way of thinking of it.
and then the second CVP would actually be the implementation of the function void print.
Yes.
Alright.
HPP header files are always defining the interface, aka they're the function headings. They can also be your class declarations as well. We'll get into that later. But then in your CPP is where you write the code.
So the HPP would always be the interface, the CPP would always be the implementation
Yes.
of the app.
Yes.
That's why I wasn't sure, like, what HPP was.
Header files, yeah. Yeah, I think I've been assuming that students learned that in the previous one. Did you, who took, so Hayes didn't do that. Okay, I mean, that's fine. I just need to know that.
That's crazy.
Okay. Never put implementation in a .hpp file. Implementation code goes in a .cpp. So notice that the headings are right here, but the code is in the CPP file. Function heading, the declaration of the interface of what it is, what it's called, how you use it, and second is how it's implemented, what defines what the function actually does.
So that's kind of like how it's a longer way of doing it how we had it where we declared it up at the top and then actually implemented it down on the bottom.
Right. You're going to, for the labs and projects here, you're going to really want to do like that.
Was that like how we did like with interfaces in Java?
Yes. So as he was pointing out, the header file is essentially the interface because it doesn't have any code in it. You're just declaring what's
Right.
what
And
it.
will it always have the if and stuff? And
Right. Okay. So the point of the if not defined is that what this does is it makes it so that once you include the header file, you don't accidentally double include it. So let me take this out real quick and show you what the problem is. This is a very contrived example, but right now if I were to compile it, it would actually work just fine, but that's only because I've written the code in a specific way. If at some point you accidentally did this, and this can happen and it will make a lot more sense when your projects become huge because you might accidentally have multiple pieces of code that have to use it that you want to compile individually, so you need to actually include the header files multiple times. If you do this and you do not have those defined statements that I have, you go to compile it. Wow, it compiled? It compiled.
What do you know?
That was not supposed to happen.
Good job.
Huh.
Did exactly what you didn't want it to do.
Yeah, let's see if that does it. Nope, it's perfectly fine with it. Oh, that's funny. What if I do this? Let's make class word. Is that going to enforce it as well? There we go. Redefinition of class word. So I guess with the function headings, it really doesn't matter. But with classes, it's going to give you a problem. We're going to go into classes. So what happened here? Redefinition of class word. Why is that an issue? You can only define, well, you're only supposed to define the class once. But since I was in here, I tried to define it twice because it took the contents of second.hpp, pasted it in twice. If I remove it and I go back, it's okay. But the reason for these if defined second and end if is that I go back, it's still fine. If I accidentally at some point or I need to include it twice for any reason, it's still fine because what this does is once you've defined it, it ensures you don't redefine it again. What's happening is when the compiler reads your code, it says, while I'm compiling, do I have something called second HPP? Not currently. Okay, first, let's go ahead and create that variable, give it a 1. I include the code in the if. I come back in, I ask, do I have this defined? Oh, look, I have it defined. Skip all this, move on. That's all this is doing. So even though the code's pasted in twice, the second time is ignored. In actuality, it's not pasted in twice because of how it's done. When it goes to paste it in, it says, oh wait, this is already defined, don't paste the contents into your
So
file.
if you had like multiple classes that needed to include second HPP.
Right, yeah.
Okay.
Yeah, you just each include each one of them. Also notice that you can do this for each collection of HPP and C file, for all pairs, as long as you give it a unique identifier right here. It's got to be unique. All right, great questions. I'm glad y'all stopped me. Thank you.
So just,
Any other questions?
why do you need the second, why did you show us that again? Because I couldn't really understand.
Why did I show you what?
The 2 header files within the first CPP, why did you call it twice?
Many times, I'm trying to show you that the error that comes up if you do not include the if not defined, defined, and end if around your header files.
Okay,
Then,
so if I don't include them, I get the error, and if I don't include them, I get the error, if I do, I don't get the error?
okay, hold on. Oh yeah, if you do not include them, you will not have redefinition problems.
Okay.
But if you forget to include them, you will have redefinition problems. So your header file should always start with the defines. Let me put that up there as well. All right. All right, great question. And then, of course, I can run it. Okay. Any other questions? Beautiful. Yeah, that makes some sense. So the point of this, if we want to make a change to one source file, the previous command would require us to recompile everything and run again. For most of our labs, that would be okay. For any real project, that would be unacceptable, because to recompile the entire project, if you've been in the real world, would take a very long time to do. So what you do is G++ or C++ allows you to compile each file individually. This is why we start dividing everything out. And you do that with the -C. So if I jump back and I go G++ -C first.cpp. Thank you. And do an ls-lh. Notice that I created a first.o. Let's do a quick file on that. File first.o. ELF 64-bit relocatable file. So it's not actually an executable, it's an object file. What happened is the compiler compiled your code and put it in a .o file and just left it as raw compiled code, so to speak. So you can compile each file individually, but when you want to actually run them, you can later link them together. So I have a .o from first. I can do the same thing. -C is what just compiles it. Second.cpp. And then if I want to chain them all together, -o first, from first.o and second.o, it links them together. So I compile each of the files individually with -C to produce their object files, .o. And then I can link them all together by just listing their .o files and instead of their .cpp files, thereby skipping the compilation phase and only doing linking.
Is first the output file?
Yeah, first is the output file that I want to run, so now I can just call first, hello world, hi there, and it linked it together. So notice that we have first.o, second.o, and then I can link it together to first. Okay, any questions about that? Oh gosh. Nothing yet? Right?
Well, don't worry. Well, I'll be watching this again later.
Oh yeah, we got a lab. Oh, it's not even in here. That's fine, we have a lab.
Oh,
Make.
Why did you have to ask?
I knew we were going.
Well, yeah, it wouldn't be get instructions. So make files, a collection of instructions that should be used to compile your program. Once you modify some source files, you just type make. And once you write make correctly, it's just going to do all this stuff I just talked about correctly. Do it for you. So you just type make. Wouldn't that be nice?
Yeah, what? What is it doing for?
You create a make file, and it does the compilation stuff for you. Wouldn't that be nice? Wouldn't you like that?
I would like that.
You would like. Jonah would like that.
I would like that.
It would make Jonah happy, I guess.
All right. So make. Now take a step back. We're thinking about something different. We have C++. Now we need to use learn the make file language. Luckily, make is actually very simple. It's extremely simple and extremely powerful. That's why it's been used for so long. and so prevalent because it's really, really easy once you get the hang of what a dependency rule is. It's okay, Caitlin. All right. First off, in make, you can define variables by just setting them equal to something else, and your variables are always containing strings. So here we have C flags that contains string -g space -wall. And then we have sources, which equals main.c space file1.c and space file2.c. And then CCC, which is just GCC. Now your make rules define the condition given file needs to recompile. So for example, if you need to compile main.o, you would start the dependency with main.o colon, that's your rule. Then you list what files that rule depends on. What that means is if any of the files that come after that colon are modified, make is going to rerun the command you put afterwards. In order to put a command, you hit a tab. All right.
Is this in the command line?
Yeah. So I'm going to go back here. I'm going to go ahead and gvim makefile. Open up a new one. And we're going to just make a rule. First.o, which will depend on first.cpp. When you use makefile, anything you want to define underneath the rule must start with a tab. That's the only slightly weird thing about makefiles, is you must use a tab. You cannot use spaces. If you use spaces, it will not work. You must use a tab. So I hit the tab key. And to compile first.o, what do? I do gcc-c first.cpp. I'm going to go and save it, and I go back here and make first.o. It says it's up to date. That's because there haven't been any changes since first.cpp was changed. So I'm going to go back over here, go back to first.cpp, and I'm going to add a line, and I'm going to rerun my command, and notice that it reran the command gcc-c first.cpp. Okay? All right. Sure. All right. I'm going to go back to here, to my makefile. I'm going to make another rule called second.o, second.cpp, and it'll just compile second.cpp for us. So it will behave just like first. And when you're in makefile, usually your first command is actually all, which is the command you want to use for everything. So we'll have it depend on first.o and second.o. And it will just do gcc-o first from first.o and second.o. So all depends on first.o and second.o, so make sure that first.o is up to date, which depends on first.cpp, compile it, and same thing with second.cpp. So if I were to go back here, and type in make, undefined reference to, that's because I was using GCC, I bet. Yeah, I was using GCC. When in reality, I meant to be using G++. Go back here, make. It goes ahead and updates first to the file. Notice I just typed in the word make, and it did everything for me. More importantly, if you lose your .o files, or you need to, or an update's done to your CPP, so for example, I'll remove all my O files, I type in make. Notice it recompiled first and second for me, and then linked them together and created the first executable for me. Any questions so far? Nothing? Okay.
Still processing.
Still processing.
We're very slow computers.
And slow beginners. I've talked about variables, so you can have C flags. These are common to what you want to pass when you compile. So I can put in debug, warn all, and optimizations level 2. So when I compile it, I just do :C flag or $, open curly bracket, C flags, close curly bracket. And I'm going to go down here and do the same thing again.
You misspelled it.
Yeah.
Oh,
It's okay.
burn.
No, you. Yeah.
It's full guys.
Yeah.
How about that?
There you go.
All right, now when I go back to my command line, I'll go ahead and remove the .o files. I type in make, looked at, now it added the compile flags, warn all, and -02 to all the compilations. Why is it important? If you want to, I don't know, remove your debug flags for whatever reason, maybe you're silly, you just go back up here, you remove the debug flags, and then you can type in make, and now it does it without the debug flags. Notice it did not recompile first or second because they had not been updated since the last compilation.
And you can just type make because you're already in first.
Because I'm in the directory,
Yeah.
which contains the make file. Make immediately looks for the make file, finds your first rule, which is all, and then goes from there.
Okay.
It's magic. So I talked about it and I didn't comment it. Come on, guys, you gotta remind me to comment.
I'm sorry.
All right.
Comment.
First, define your variables. Comments in makefile start with a pound. All is by convention the first rule. It goes, what was it? Rule name colon dependencies.
Why do you have to put a $sign brackets around C flags?
It's best practice to do that. Let's put it that way. Tab, commands.
Is that a class code?
Yes, and remind me to push it at the end, because sometimes I forget. All right, so what does all do? Let's start there. Let's see who's with me so far. What's all do? Huh?
Try it.
It checks if,
Spacing in and out.
checks if first .o and second .o have been changed. And if they haven't been changed, then it just runs that line there and compiles the...
Close. All depends on first.o. Is first.o defined in this makefile?
Yes.
Yes. So it jumps to that rule.
It checks if it's updated or not.
Hold on. Yeah. It goes down here, first.o, so it checks this rule. What does this rule depend on?
First.cpp.
Is first.cbp in this makefile? No.
No.
It checks the hard drive. Does first.cbp exist?
Yes.
Is first.cbp older than first.o? If it is older, that means we don't need to recompile our flags because it's already up to date. If first.cbp is newer than first.o, that means we need to rerun these commands, and it goes ahead and compiles it for you. So that was first.o. Now it's going to check, oh, we have a second dependency, second.o. Is that defined in the makefile? Yes, it is. We jump down here. Second.o depends on second.cpp. We check the hard drive. Does that file exist? Good, it does. Is that file older than .o? If it is, you don't need to run the command. If it's newer than second.o, then you need to recompile these commands. Now that the two dependencies have been fulfilled, we jump back here and execute our final command, which links it all together.
How many .os are we allowed to have?
Any time, any number you want. You can have a million. I don't care.
How would we do it if we had more than that first line?
So we would well, you could just copy and paste everything for each rule if you wanted to. In a little while, I'll talk about, not today, but I'll talk about inference rules and makefiles that basically generate all these .o and CPP rules for you.
So I may have been glitched. What's the actual command C flags represent again? Like the actual word?
That is not a command, that is a variable. We first define a variable called C-flags that contains the string -wall space -02.
Got it. Okay.
You don't need to use quotes in makefile.
So this whole thing, just making sure, because there's a lot we're learning here, is it checks if it's compiled or not, and then it updates it if it is. If it isn't, it just keeps going.
With first.o, it's checking, is the source code file older or newer than the object
Yep.
file?
Okay.
Right.
We're speaking the same thing.
Right. So if it's older, aka
Compile it, if not.
no, if it's older, then that means that first.o is newer, which means it's already been compiled. If first.cbp is newer than the object file, that means a change has been made to it since the last compilation, and you need to recompile it.
Okay.
And then make automatically does that for you.
Here we go.
Doing great?
Well,
say
it's a
so.
lot to take in. I'm trying to type it myself. It's just a
Feels
lot to
like we
take in
didn't have
every
a
day.
Huh?
It feels like we do. I I'm already
No,
tired.
Well, if it means anything to you, we do have Monday off, although
Mondays, Mondays is class.
Great.
So,
I thought it's a double-edged sword
Yeah.
because do celebrate MLK Day, but you may need to do some work on makefiles
or watch this video.
or watch this video.
Yeah, I'm gonna be.
All right,
I'm gonna be at Warzone.
we'll keep going. First, you list your variables. Top level rule to create. Typically, top rule is all by convention. Compiling source main.o depends on main.c in this example. Notice that here I define cc to be gcc, so I can use that right here at the beginning. Literally, when you are using a variable, it is just substituting the variable name with whatever its contents are. So here we have main.o depends on main.c, and then later we have main, which depends on main.o, which compiles on main, and then all just actually is a rule to compile main. Oh yes, clean. Clean is one of my favorite. Again, hopefully this makes sense. So clean,
Clean stuff up.
yeah, we're just going to do rm-f, so no one asks questions, .o, and the first executable. So if I do an ls right now, I have all these files. I do make clean. I do an ls. It cleaned up those files for me.
What do you mean?
Does it mean you got
Deleted them, removed them. It removed all your object files. And this is a very good thing to do because you don't want to be sending object files around because those are usually far larger than your source code. And no one likes it when you commit your object files. Please don't commit your object files. That's like committing your class files in Java.
Oh.
It's the same thing.
So
Don't do that.
if you're gonna get rid of the object files every time you run make,
No, it doesn't because I type in make right now and recompile.
you do make clean.
Yeah, make clean got rid of the object files and the executable. I type in make. Well, there's no object file, so I knew it had to recompile it. So it recompiled it all and then linked it all back together.
So before we push stuff,
Make clean.
make clean.
Make clean.
Clean. Like Mr. Clean.
Like Mr. Clean. You know, if that made you happy, you could do this. Mr. Clean is just clean.
Then you have to do make Mr. Clean.
Yeah.
Well, Mr. Clean and clean are going to do the same thing.
Mr. Clean. Clean my house.
Yeah. Again, just to iterate, make, since I cleaned it, it created the object files and compiled it. I type in make again. It did not recompile the object files because they're already up to date. So notice that the next time it compiled, it was a lot faster. If you have 20 files here, and each file takes, I'll say, a second to compile, the first time you compile, it takes 20 plus seconds. But then if you only update one file, it only takes that 1 second to recompile that one file, as opposed to the whole thing.
Okay.
So that's the running program is basically all day.
This compiles it, and then to run it, you do first. Although if you wanted to, you could do run
All days.
first, and have run depend on, let's see, all. So then you would go
So like if they all compiled it in a run.
make run, recompiled, relinked it, and ran first. There it goes. So if I do make clean, and then make run, recompile everything, then run it. Now you only need one command. This is why make is so powerful. You really are just delegating out all the different subtasks. Make is taking care of which task needs to actually accomplish, and you can make whatever rule you want to do whatever you want because make is just executing commands on the command line. Magic.
Easier.
Does this at least look easier than having to type everything out?
Yeah.
No.
But once you type it out the first time.
Once you learn it, it should become easier.
It's going to become a lot easier.
I don't know. I like this.
So will Vim, but Vim's gonna take you forever to learn.
Copy pasta.
Yep. I really want to make that site steal from the best, and I'll have all these examples up there. All right, multi-source one. This is similar to what we have, all as program, which depends on main.o, file 1.0, file 2.0. Notice here we have rules for main.o, which, let's see, that depends on main.c and some header files, file.o, c and header files. and file 2 is the same way. Notice that you have to figure out which header files and C files they depend on to make sure it actually updates your files correctly. And then, of course, clean the whole thing up. And don't forget, gotta be squeaky clean. The reason why make is so powerful is commands can be anything. Normally you use G++ to compile and link, but you can make the commands whatever you want them to be.
That scares me.
A lot of times, it's kind of, I had one professor who's all about Linux, and he said, Paul, the reason you're my favorite programmer is whenever you hand me a gzip file, I unzip it and I type in the word make, and it just does it. I don't have to figure out what it is you're even doing. I just type the word make, and it happens. In the Nix world, that's what it comes down to. People just want to unzip your thing and type the word make in, and let it be, because they don't want to deal with anything more. But there are other tools, multi-line. So there is something called make param, runs dependency for param. If you want to look into this, this is a way to start learning how to develop or automate the creation of make files. It's not too. If you want to look into it, you can. Make depend is another tool that generates all the make files for your C files. You can do make depend and automatically create your make file for you. Unfortunately, it's not the best. So I still recommend writing your own make files. Lastly, you can do something called configure. Again, it makes files. Finds things like, but it actually searches your code and figures out what libraries need to be installed. For example, if you're using Tickle or some other library like OpenGL, it'll, yes, TCL, Tickle TK. And what it does, it creates a configure, which when someone unzips it, they run configure, and it makes sure all the libraries are installed. And it makes your make files correctly. But we'll just be writing our make files ourselves. Debugging. All right, I talked about adding the debug flags, -G. So let's jump over here. And we'll put our G flag back in. Make clean, make, good. And then you can do GDB first. Let's do this first. So GDB, yeah, it spits out a lot of output. AKA, there's no warranty. Don't sue us if this breaks your entire system, blah, blah, blah. GDB, your executable. Notice I passed in the executable with the / in front of it. You have to do that.
Why?
So it knows where the file is. Read the symbols from first. We're good to go. If you want to run your program, you can just type in run. And it says starting program first. Hello world. Hi there. Inferior process 1 exited normally. All right. This means that GDB said, hey, your program ran. There wasn't a problem. We're good. You're good. All right. If you want to quit this, -Q quits the debugger. Or just Q, enter. Let's see, you can type in run. You can pass in parameters if you want to. We're not using parameters too much right now, so I'll go over that again later. If you wish to set up a breakpoint, we did breakpoints in Java, right? Briefly. You can type in, specify a specific line of code to stop, like break 9, assuming only one source file. Otherwise, you got to do source file :9. And it'll be on 9's a line number. So, for example, let's go back to our first. Let's say we want to break right here, which is first line 8. So we'll jump back over here, GDB first, break first.cbp line 8. Breakpoint file is set up. Then we type in run, and it goes, all right, starting first, hello world. Whoa, we hit the breakpoint. Breakpoint means we're stopping execution on line 8. In case you want to figure out what the state of the machine is as a certain line of code. If you're trying to debug why things aren't working, you're like, okay, things stop working here, let me set up a breakpoint what are the contents of my variables? How have I gotten to this spot? The debugger will answer these questions for you. So right here I can do info stack. Currently I'm in main, so that didn't help too much. Where am I is actually the same thing. Let's see what we call it. And then I can type in next, which prints out hi there, puts me to line 11, and then I can type in next, and it actually returns back from the direction, so I'll just type in the word continue, and it finishes my program and ending execution. All right, so let me at least give you an example here. Let's go jump over to second.cpp, and I'll do int a equals 500. And a lot of times if you're trying to compile, it is really best to remove, whoops, that's not what I want to do. Tab new, let's open up makefile here. Quit this thing. Go back here, open up the makefile. It's best to turn off optimizations so it doesn't accidentally optimize something out. So I'll do make clean and recompile everything. Ooh. Unused variable, that's a warning, so we don't care. GDB first. And then we'll set up a break on second.cpp at line, where are we, right here, 5. And then we'll go ahead and type in run. And now I can ask, where am I? Well, I was in main. On line 8, I was called print, which is located at second.cpp, and I'm currently on line 5. Okay? Sure. All right. So now that I'm here, I figured out how I got here. Let's see if it tells me. I can go, so list pound, sorry, A. What are you doing here? Shows the line number in the next few lines, hit return. Yeah, that doesn't exist. I wonder what it's talking about. Print. Oh, there it is. All right, you can list the code from here if you really wanted to, but you can just open the code in another window. I wonder why I did that. You can, let's see, breakpoint, you can continue. Where's where you actually look at a variable? Print, there it is. You're at this value, you want to know what the value of A is, you do print A equals 500. Huh? $1. It's basically storing $1 to 500 for you, because if I do it again, $2 is 500. Just a way to store temporary information. But notice you can look at the values of variables using the debugger. And you can go line by line by typing in the word step and stepping to the next line. So if I type in S, hi there, I'm over there, and then now I'm at the return, hit continue to exit the process. Okay. Talked about where, talked about printing. Oh. When in the past, whenever your program crashed, a core file would be dumped. It would literally say segmentation fault, the core has been dumped. Nowadays, it doesn't dump the core. The cool thing about a core is you can GDB the core and go in and find out where it broke, find the line it broke at, and what the variables were at that point, which would actually give you a lot of information about what was going on. It doesn't do that as much anymore. You just need to run GDB and get to that point. If you actually ever are able to get a core dump, which means you did something impressively bad, you can still run GDB off that core. Impressively bad, yes. I can't think off the top of my head how to do it, but I've seen it done. It happens. You can run a GDB on that core, and it'll actually get you to that point. Let's see, run, checks if it's changed, but doesn't do I just get rid of GDB and come back to it. There is a GUI wrapper for GDB. And this one is actually fairly simple, one of the nicer ones. Instead of running GDB, you type in DDD. It's a bug. So here you can actually set up watch points, break points. But for example, where we're in main.cpp here, let's go look, do it.
Do it.
Just.
That's not what I want. Where's source?
Just do it.
Look up.
Click it.
Hold on a second. Where am I? Oh, I double click on print and I can actually go into the print statement. And then I'm right here and I can, come on breakpoint, breakpoint right there. So I can set up the breakpoint. Then I can tell it to run or hit the breakpoint. And now you can hover over A and it'll tell you what its value is at that point, which is 500.
That's cool.
And now you can click step, and notice it goes to that line, it goes over to the return, notice there's that green arrow telling you where you are, and you can keep getting step, and then when you want to just keep going, just hit run.
Why is there two different steps?
So step and step in 2, good question. Let's see if I can remove this breakpoint, clear that breakpoint. Let's go back into main. It's not letting me go back into main. That's cute. There we are. If I put we'll put a breakpoint right here. And now if I run the command, if I do step, that's step in 2, or it does one instruction exactly. Okay, it's a little different in DDD. And now it actually steps into this function, and it's going to do it one step at a time, very slowly. Let me run it again. Well, on the other hand, if I do step and I go step, it's going to actually do it one line of execution at a time. You don't know what an instruction is, so don't worry about step I. This tool can help you with debugging. If you need some help with it, you can kill the process? Yeah. I can give you a little more pointers. Huh?
Said you're killing things again.
Well, that's common.
Sometimes you gotta.
You just gotta do it. All right, how are we doing? Okay, good, we got time. Real quickly, system architecture and device. You just keep this in the back of your mind. Actually, we never need to know this.
Never mind.
So I'm going to tell it to you anyway.
Like for this class or like ever?
This class.
Oh, okay.
When you take operating systems, this will come back.
Then I'll go back and haunt you.
I don't know about that. Keep in mind that there are low-level functions that are used by the operating systems and high-level functions used by your programs. Making a low-level system call is expensive. High-level system calls are generally not as expensive unless they have to make low-level system calls. So, this picture really tells it all. Your program's running up here that we wrote. You use the library, namely the C++ library. If that C++ library has to interact with the device somehow, aka your keyboard, your monitor, or whatnot, it'll then make a system call to your kernel, which then communicates to your device driver, which then communicates to your hardware device, and then any input comes back up the stack. So, the point here is you want to stick in user space. We are staying in user space. We're not going into kernel space. And that way the library can take advantage of that. If it doesn't need to make a system call, it won't. But that's why in our codes, or at least in this class, we're not dealing with functions open, read, write, close, ioctl, because those are actually system calls and would actually jump from user space to kernel space, and that can be an expensive jump. Okay? All right, great. Valgrind. What even is?
Sweetest name ever.
Sweetest name ever?
Yeah, it's the sweetest name ever.
All right, Valgrind is going to be your friend in this class.
Your friend or your enemy?
Oh, it's going to be your friend.
From
It's going to be your friend.
Oh, it's going to be your friend.
It's going to be your best friend.
If you wrote a piece of C code, if you wrote a piece of Java code that accessed something out of the bounds of an array, would Java stop you?
Yes.
C++ does not.
Oh, great.
And then
The training wheels come off.
Right. Valgrind will tell you if your code is accessing something out of bounds. So when we get into heavy memory, which you will have to use for pretty much all of your data structures, Valgrind will be used, or is very handy to tell you if you're having memory problems. Because if your program is behaving strangely and it makes no sense, I can almost guarantee you with over 90% certainty that you probably have a memory problem. So run Valgrind. Yeah. It does a lot of things, but for this class, we're just going to use it to track memory. So we're doing a successful run right here. Let's go ahead and jump over here, and we'll do. We'll close this, and we'll go in. I'll just call it valgrind.cpp, and we'll just do include iostream int main int argc char star argv. Return 0. All right. Now if I do g++ valgrind, and we'll go and output it to val. I run val. Everything's happy because the program doesn't actually do anything. But if I were to run valgrind on val, valgrind / on val, memory checker, copyright, etc., heap usage, no bytes, no Alex, no freeze. All heap blocks were free, no leaks are possible. What was the heap?
The bottom.
Yeah.
The bottom.
Yeah, the bottom.
What was allocated to the heap in Java? Objects, right. Objects were allocated to the heap. Java automatically deallocated your objects. C++ will never do that.
So how do you delete an actual variable in C++?
You run the word delete.
Oh, that's it. Can't you just make it null? Or does that still take up memory?
Oh yeah, let's do that. Let's do it. Let's watch what happens.
I have a bad feeling about this.
So int star, we'll call it array equals new int. We'll make 500 of them. Because I'm creating a pointer. When you write in C++, when you create a pointer, you must be explicit about your pointers. In Java, they were implicit. All objects were pointers. In C++, you must use a pointer. Yes.
Stupid question. What's a pointer again? Just from.
A pointer is a variable that holds a memory location.
Okay.
It points.
So it points to something. It's pointing.
It points to something.
It points at something.
It points at
Kim
something.
Jong-un points at things.
So I have a variable called array, which points to integers. By the way, this is something you can never do in Java. Points to an array of integers because you can't allocate primitives on the heap. But you can in C++. And then I'm going to create 500 integers somewhere on the heap. It's going to come back and give me a pointer to it, and I'm going to store that in the variable called array. All right, let's first compile it and then run valgrind. In use at exit, 2,000 bytes in one block. One alloc, no freeze, 2,000 bytes allocated. Definitely lost 2,000 bytes in one block. Ooh, sadness. Ooh, not good. So now, can you just make it null and be happy? Well, let's see. We make it null. In order to use null, you have to include stdlib.h. So let's go ahead and g++ that, and then valgrind again. Nope, that didn't do anything. You literally have to do delete array.
Why does delete have brackets after?
Because in this situation, I'm deleting an array, and when you delete an array, you need brackets. If you're deleting one variable, you would not use the brackets. So now I ran delete. Heap summary, one alloc, one free. All heap blocks are freed, no leaks are possible. Woohoo! We finally have a program that uses the heap in C++ and does not fail. Oh yeah, you have numbers over here. These are your process IDs for this class. They are meaningless. Just ignore them. So if I have this example where I create a bunch of integers, same problem we just talked about, but if I finally delete them, then they come up free. Another reason that Valgrind will be very handy for you. For int I equals 0, I is less than or equal to 500, I plus plus, array sub I equals I. What's the error?
The array is just going to be deleted, so it's just a useless for loop.
Huh?
The array is going to be deleted, so it's just a useless for loop.
Oh, okay. Yes, semantically that's correct. But what is wrong with it actually as a program?
Going all the way up to 500, but the array has 500 items, but it goes 0 to 499.
Right. So we're accessing the 501th item. Java would stop you.
Will we be covering multi-dimensional arrays in this class?
No, C++ had no problem and ran it just fine. Fine. It looked like C++ ran our program just fine and there were no problems. But if you allocated your array here, and then right after you allocated something else and the operating system decided to put it right after the array, when you edited the 501th item, it would overwrite whatever you had right there with 501, which would equal sadness later on in life. And it would make your program behave very strangely. You would not understand what's going on. Let's see if Valgrind can help us out. Whoops. Invalid write of 4. Woo. So we allocate and deallocate correctly, but an invalid write of size 4 in blah, 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 0 block after 2,000 bytes. All right, so it's not really helpful what's going on, but that's because we don't have our debug flags. So let's add our debug flags to it and then rerun. And then it says, okay, address main with operator new, Valgrind line 8. So it's saying the problem is right here. For some reason, the I is not, when it's being written over, is overriding the bounds of some allocated block. That's what
Where does it
Valgrind.
say line 8?
Valgrind.cpp line 8. Not a problem. Good question.
Dash tag G is the debug flag.
Yeah, make sure you compile with debug flags. So we find out, oh wait, the error is we're doing less than or equal. We get rid of that equal sign. Recompile, run Valgrind. Now we don't have any problems. Ta-da. So is this nicer or more annoying than Java?
Oh,
Because Java used to delete it for you, didn't it?
Yep.
Oh, I was gonna say.
oh.
Definitely more annoying.
Definitely,
More work.
definitely more annoying. When you use C++, and it's still used a lot, you have to do memory management yourself. But what would be the advantage of doing memory management yourself?
Correct.
You get to have more power and more control.
More
so
control.
If you want to screw one of your coworkers over, you can always do that.
Okay, there's that. But for your program, what does that mean over Java? There's the possibility that flexibility and
Segmentation faults.
segmentation performance. By doing it yourself, you do a couple of good tricks, your memory management will be superior than Java's. Java has a very, for generic garbage collection, Java's algorithm is actually good, but in general, doing it yourself will be better.
Always
With a
remember,
couple.
JavaScript is always used and abused by new and inexperienced programmers. JavaScript's a web scripting language.
Did I say JavaScript?
No.
No, I said JavaScript.
Okay, good. So, yeah, right. You got to learn to use it properly.
Yeah.
And Java does a lot for you, but if you're in high performance, it may not be the best choice. All right. I think that's going to be it for lecture, because in the future we'll talk about gproc, GNU plot, but next, before we learn those two, we need to learn a little bit more about Bash, which is your shell scripting program. So let's go ahead and jump over to Lab 2. Oh, good.
You sure you want to do that?
Oh, yeah.
Just Lab 2.
All right, what do you think we're doing in Lab 2?
Okay, so I
Big
have a
file.
question. We have to like push,
Print your name.
right?
Oh, yeah, hold on.
We have